an ambitious title to live up to. We'll see. What I mean by nearly anything is I want to sort of cover a whole bunch of introductions to different sort of the coolest technologies that I got to play with over the last year or so in JavaScript. But before I do that, I want to sort of go into a bit of a story, a bit of why I ended up touching all these weird, completely unrelated at times APIs. And that's because I came up with a simple idea, simple to implement, a couple months maximum, idea that I wanted to control my little 3D printer over Wi-Fi. I figured, you know, like they say in Top Gear, how hard can it be? If you've seen that show, you know how that goes. So I set about making it, and actually a couple months in, you know, right on time, I did have sort of a prototype. This is what I had at that point. You'll notice a little bit of familiar WebGL kind of stuff going on here. So what you're seeing is in the center there, it's my little guy, my little cute octopus. That's the guy I want to print on my 3D printer. I've got a build platform, my 3D printer's build platform underneath that, so that's sort of a stylized, simplified version of part of my printer to show me what it would look like in reality. And the blue cube is sort of the total area that I can print in. So just trying to make it really obvious how big this thing's going to print, and, you know, is it going to go out of the bounds? You could do simple transforms like scaling it and stuff. There's still a bug where it changes color when it scales. Very prototypey, right? So what was cool about this to me as a developer, this will sort of be interspersed story and also technologies that went into a couple prototypes here. What was really cool about this to me as a developer was really different than what's cool to it to, you know, sort of my mom when I show her it. What's cool to her is that it's got crazy 3D things happening in the web browser. What was cool about it to me is actually what happens before that, before we even get to the point where we're showing this little guy in the web browser. The very first interesting little bit here is that this is not a normal web page. That is not how a web browser looks. This is a Chrome unpackaged app. And what that means is it sort of straddles the divide between web pages and Chrome extensions. It's sort of a website that you can download to Chrome and run more like an app, more like an Android app or an iPhone app. It's sort of, you're installed into the web browser and you get access to a lot of really useful proprietary APIs. That's one of the technologies I'm going to go to once we get to the technology part, past the story part. But way more cool than that. What I'm doing here is a little bit different than what you're doing on a traditional website. You know, the traditional website, first off, has a server. That's sort of a defining characteristic of websites. There is no server here. So when I open up this file dialog using, you know, the traditional input type equals file that we've all seen and done a million times, I'm not actually uploading it to a server when I hit open. What I'm doing is I'm actually processing that. I'm using the HTML5 file API to get access to the content of that file and then actually go through there and parse it. So it's a native, you know, 3D model format, STL, and I take that, I parse it, you know, getting access to it through that API, parsing it, it's actually a binary file format, so I can't even parse it with, you know, string parsing like we do a lot of times. You know, JSON is fundamentally a string-based thing that we can pass around, same with XML, and so JavaScript has really good tools for that kind of stuff. When you start talking about binary things, that's something that JavaScript hasn't really had tools for until really quite recently. And so with the invent of typed arrays, which is another one of the technologies we're going to talk about, you're now able to deal with binary files. That to me is a hugely important stepping stone as we're going from sort of dumb documents, you know, the original HTML, what it actually stands for, hypertext document, to web applications, things that start to approach where native applications are and start to sort of come into their territory and challenge them a bit in that respect. One of the things we're going to have to deal with in desktop environments, as we're getting there, is the file formats that people already have on their computers. So that means legacy stuff. That means, you know, industry-specific, horrible formats that go back to the 80s or the 70s or whatever, And back then, now we've got terabytes. Back then, you spent a couple megabytes, it's a problem. So you're dealing with all these different binary formats. And if you didn't have this typed array stuff, that was going to be a massive stumbling point. So one of the things we're going to talk about is how you deal with those formats. The other thing is, you notice it took a little while to load that file. I'm going to go back a little bit here. Load up another file just to show you guys again. Where's that hedgehog? Big fan of hedgehogs. That's always my test print for some reason. So it takes a while to load. That's an optimization problem. Definitely can be fixed. But initially, when I made this site, that's actually a really intensive process going on the CPU. The CPU is just like burning at that point. If you look at it in top or something, it's like fully on. If you do that with a normal website, your browser's going to lock up. Users are going to freak out, and they're going to kind of try and desperately close that tab. Sometimes you can't even close that tab when you're running just like an infinite loop in JavaScript. So it's just like the worst possible situation in terms of usability, in terms of user experience. What I did to mitigate that was I switched over to web workers. So that's one of the technologies we're going to talk about as well, web workers. Cool. I sort of wanted to just give a brief introduction to how these things all connect. Now, to finish off my story, I spent a couple months, built this prototype, was pretty pleased with myself. Took it to some friends at HackLab, because HackLab was where all the 3D printers I was using doesn't matter. And I said, what do you guys think? Like, I want you guys to try this out because, I need some people to bounce this off of. I want a really good sort of group of people to test it with. And they came back to me with 2 things. One, super cool, 3D things in the web browser. Similar response to my mother in that respect. 2, we would never use this. So I found that second one kind of interesting. I found it a little bit discouraging, possibly. But I went back to the drawing board and I thought about it. And I realized that when you're developing something for a really technical audience, for developers, for people who are closer to web developers than sort of your average customer, you're actually dealing with people who are really perfectly fine, actually happier to deal with command line interfaces. In a lot of cases, it just fits better within our workflow to be able to have something in the command line. So I scrapped that, I put it on GitHub, just left it there to rot, and I came up with this. And whereas that was a little prototype, this guy I actually got to work. So if you have a 3D printer in the room, you can automatically detect it with this through using MDNS and DNSSD. This is a nodeJS command line interface to your 3D printer. It works. The thing that was really useful once I got to this point was I could iterate it really fast. Because designed it wasn't a factor anymore, only usability mattered, and you could really sort of try features out quite quickly with this crowd that were okay with this kind of interface, and it was just amazing how quick it could be iterated. The only technology I'm going to talk about from here is how I actually talk to the 3D printer, how I send commands to it, how I receive commands, how you can see up at the top I'm getting temperature data, about 2 different temperature sensors on my development mock 3D printer. That's through WebSockets. And that's going to be probably the briefest thing in this talk. Who here has heard about WebSockets? Not everyone. Okay, that's bad. It's not everyone. Okay, who here's used WebSockets? The exact same people. Okay. Is anyone asleep? You, sir. Okay. Cool. So let's start with the manifest. So this is sort of my very basic hello world of Chrome apps. This is a Chrome unpackaged app. Difference between Chrome unpackaged and packaged, nothing really. Your app starts as unpackaged when you're developing it, and then it becomes packaged when you sort of deploy it to the world. Very basic. It's actually similar to Chrome extensions in how these files look. You give it a name, description, version, all very self-explanatory. It's the version number of your app. Manifest version, this is always 2 as far as I know. This is just to do with the actual semantics of this file. The app is where we start to get into things that matter. What we're saying here is take the file js/background.js and run it all the time. It's my event listener for this Chrome app. And in a similar way to how in jQuery you're going to be listening for a document, on ready, in this JavaScript file, this background file, we're going to listen for when they try to launch the app. So I'm just going to quickly detour to show you guys that. Very simply, adding that event listener for when they launch the app. And then inside of that event listener, on the second line, I'm opening up this index.html file using a whole bunch of Chrome proprietary APIs. This is all available online. I'll give you guys the URL at the end. So that's how you get into it. But let's go back to the manifest for a second. And I just want to talk about a couple other things here, which I didn't need for the hello world. But if you guys want to go after this and make your own Chrome apps, these are probably things you're going to need to use. The requirements. This is where you talk about the different APIs you want to use. So it's a bit different than HTML normally, or making a site normally, in that this is really, really sandboxed here in the Chrome apps world. I don't really know why I think it's like to the side of like paranoidly sandboxed at this point, but like if you want to use WebGL, you can't just instantiate a WebGL context. It's just going to say those functions are missing. You actually have to add it to the requirements list that WebGL is one of the technologies, one of the APIs that you want to have access to in this app. So what's going on there is Google's created this walled garden kind of thing. They've created APIs for things like UDP sockets. That was actually why I made my app, my site as a Chrome app, was I needed to make a UDP socket to try and discover all the 3D printers. That's awesome on the one hand. Got these proprietary APIs. If you need one, it's there. Horrible on the other hand. If you think about the open web, this is really going back to browser wars kind of territory and really a bad direction for compatibility. Icons, pretty straightforward. It's sort of like an app store, it is an app store. So, when you click to buy it or click to download it, you're clicking the icon. When you click to launch it, you're clicking the icon. Straightforward. They're 128 pixel by 128 pixel images. Permissions, again, very different from a normal website. You actually need to explicitly tell it all the URLs that you're going to make AJAX requests to. It's bizarre, but they've implemented a very different cross-site scripting permissions model for these Chrome apps. So if I want to make requests to, say, Google, I need to add a blob style identifier there. I just need to add each of the servers I'm going to be accessing to that list. All right, that's sort of the basics. The index.html, nothing particular difficult here. Hopefully you guys recognize this once or twice. All right. So then you can just go into Chrome extensions and pretend you didn't see the previous version installed. And click, just load it. You go find that folder that you created in, where the manifest is, really straightforward. It shows up in the list. Now I can go to this apps button, which is probably tiny, and it's showing up on the list. And that's it. You've now got a Chrome app. You've now got access to all sorts of crazy APIs, and it's going to work offline. It's going to sort of persist with the browser wherever they go. So if you want to use the web in that way, in a sort of more native way, that's a tool available to you. All right, I'm going to move on to the next thing. What's up next is, let's do typed arrays. So what's going on in the typed array at the very start of this example is we're making an HTTP request, an AJAX request, to this assets pawn file. Fairly straightforward, really run-of-the-mill AJAX request. The only thing that I'm doing a little out of the norm here is you'll notice that I've specified the response type to be a blob. This is where we start to get into new stuff. The blob API is part of the HTML5 file API, and what it's giving you is the ability to have files that live in the browser. Sort of these UUID identified files that you can just dynamically create and then then reference just like any other file. Really, really useful API and really useful as we move towards more native applications. Like if you want a user to be able to create something in JavaScript and without hitting the server, download it and save it to their computer, you're using a blob. If you want to get access to, in this case, a file that you loaded through Ajax and get access to its binary data, exactly what we're doing in this scenario actually, you need a blob. There's sort of this really useful way to reference your files a number of different times and really pinnacle to a number of the technologies that are now coming out in terms of HTML5 JavaScript APIs. So I'm going to scroll down a little bit here. We've got an onload callback, and that's defined right here. So once we load up that blob through our Ajax request, we get the XHR and object, and the response is actually, instead of sort of the normal JSON or plain text or XML, it's actually the blob object now. It's one of those, an instance of that HTML5 blob object. So what we're doing here is we're creating a file reader. Again, this is a new object you're going to see in HTML5, in the HTML5 file API. This guy allows you to take a file, whether it's a blob or any other kind of file, and open it up and read it into a particular data format. So this is where you start to take it from sort of the abstract file descriptor and you go to, okay, this is something I can start to work with my code. In our case, we're reading it as an array buffer. Array buffers, now we're starting to get into typed arrays. So it's sort of, these technologies, the file API and the typed arrays really go hand in hand here. So we're going to scroll down to the callback for that. The array buffer is, you can think of it how many of you are familiar with pointers? I should probably just quickly check. Someone's really familiar with pointers back there. All right. So a pointer, for those of you who didn't raise your hand, it's really just saying, it's just a location in memory. Behind the scenes, all our variables in JavaScript and anything else are stored in your memory somewhere, in the RAM of the computer somewhere. And to access those, you need to know where they are. So you can create another variable which just stores the specific location that they're at, the specific sort of slot in your memory that variable is at, that object is at. In our case, for the array buffer, it's basically consisting of 2 pointers. There's a pointer which points to the start of the array buffer and a pointer at the end. And that's basically a continuous region of memory that's storing this binary data that we've gotten. Really, that's it. It's a descriptor of a region of memory that we're going to treat as binary data in JavaScript. It still has no real intelligence, so now we're going to yet another interface. There's sort of like a lot of steps we need to go through to actually finally get it into a usable format here. This next one, data view, is where we actually get some real power. So there's a couple different types of interfaces we can sort of build off of the array buffer. Data view, in my opinion, is like by far the most useful. There's a few float32 array, all different types, int16 array, uint16. There's a number of these arrays that are for sort of data which is going to be, a bazillion integers or a bazillion floats, but like every single thing in your data is going to be exactly the same type. I've never had data like that, actually. Like, I'm always dealing with data that's like realistically some kind of complex structure, like it's a file format, and you need to parse it, given the rules of that file format. In this case, we are dealing with a file format. Like you guys saw up at the top, we were loading that .stl file. That's actually a 3D model. So we're parsing it using the rules of those STL files. So what data view gives us is a more generic interface. So down here, I'm going to sort of skip my little bit of mapping there. Down here, on line 30, I'm starting to make use of that data view, which I wrapped around the array buffer. And we're using the get float32 function. Sorry, method. I've been doing too much Ruby recently. The first number there, the first argument, that's the offset. So remember our array buffer sort of is like a pointer to the start of the memory region. Well, when you're trying to access a particular number in there, you're accessing it by its offset from that position at the start of the file. So what I'm saying here is, in my math there, I'm saying I know that an STL file starts with an 80-byte header. So I say 80 bytes plus j plus I times 3. What's going on there is, I know after that 80 bytes, it's going to be a series of float32s. And now those float32s, the first 3 is going to be a vertice, an x, y, z coordinate. The second one, the second set of 3, again, another vertice. Third set of 3, again, a third vertice. And those 3 vertices together are going to sort of form a triangle. They're going to be the points of a triangle. So this is sort of how we would load the first triangle of a 3D mesh into the web browser. The reason multiplied by 4, a byte is 8 bits, float32, 32 over 8, hence the 4. The second argument, this is specifying whether it's little endian or not. Endianness is really sort of a computer sciencey kind of thing. There's 2 ways to store numbers fundamentally. There's little endian and big endian, the details of which don't really matter much. If you're loading some binary data, you're going to have it documented. It's going to tell you whether it's little endian or not. But this is where you put that. This is, you need to sort of specify that. So again, just to sort of say why the data view is really the most useful interface to an array buffer, in my opinion, it's because you don't just get float32s. You can get, an unsigned integer. You can get any kind of data that you need to get out of that thing. You can get through this interface. And you just give it offsets. You tell it where to find it. You tell it what type it is. It gives you it as just a plain old JavaScript number. Right, so I'll just sort of finish up what's going on in this example, just really briefly. So we're taking the numbers 0 to 2. We're mapping on them, meaning we're creating a new array for each of the values at that. We're creating a new value for each of the values in that array, and then outputting that as an array. That's really kind of irrelevant here. Basically, we're going through, there's sort of 2 loops here, and we're creating an array of arrays containing the actual vertices. So each time we run this inner loop, we're getting 1 vertice. In here, we're getting 1 vertice. We do that 3 times, we end up with, not a vertice. Each time we run this, we get a float32, a number on, x, y, z. We run that 3 times, we get a vertice. We get its 3 sort of values on the different axes. We run that 3 times, we get the point. And then the last thing in this example is risk console logging. So I can sort of show you what that's all about. Cool. So you can see our first vertice is at basically 0, 0, 0. That's like 10 to the negative 42, so 0. Next vertice is sort of over there. And next vertices, well, it's kind of hard to do in 3 space, over there, roughly. So, we're starting to draw the triangle. Yeah, that's a rough primer on how you're going to deal with binary data. Like I said, I think, legacy data is just something we have to deal with. This is how you deal with it. Okay, next up we've got web workers. A web worker is a second process. Normally when you're writing JavaScript, we're writing it in a single process. That means that, even if you have, like, say, 2 events that come in at the same time, they're going to be executed sequentially. You're going to sort of deal with the first event, run that code, and then deal with the second event and run that code. There's never a time when 2 bits of code could be running at the same time in parallel, because there's only one process going sequentially that can run code. When we spawn off a web worker, we get a second process, and that means that we can do now 2 things. We can do 2 things at the same time in parallel. So we can have that web worker deal with some really computationally intensive stuff, and have our normal process still stay really responsive and good for the end user. You can spread up, you can keep going with that. You can do, 4, 5, 16 web workers. This is going to be really useful, not only as we get towards web applications, but also with the current sort of trend of CPUs. A while ago we were looking at dual cores, then we were looking at quad cores. Now really good machines are looking at 6, 8, 12 cores. That number keeps going up. That's sort of the new Moore's law of computing power in desktops and also in cell phones. So web workers are going to give us the ability in the browser to really harness that newfound power and really do some more powerful things that we've never been able to do before. We simply couldn't do hard computation in the browser without a lot of workaround. So this example, I've got a little flag up here we're going to demonstrate what this example looks like with the web worker, what it looks like in sort of the horrible apocalypse, which is not with the web worker. What we're doing here is, this is our web worker function. I should sort of prefix this. Normally web workers aren't done this way. If you go online and you search for web worker hello world, it's going to be like 3-4 lines or something. It's dirt simple to do a really easy web worker, but it's not practical. It doesn't actually work with how at least I work as a web developer. There's this idea of minifying and concatenating your JavaScript, of taking all the different JavaScript files that you've made and crunching them down into one, and that's the thing that you actually ultimately send to the client. That's a pretty standard process. I'm not really seeing a lot of things that are dealing with JavaScript files in a different way because that's the most efficient way to deal with them. Traditionally, the web worker API expects you to give it a file. It expects you to give it a second file, a second JavaScript file that will then be run in that second process. So when you start to have your main process and your web worker, now you have to send 2 files. Okay, that's not the end of the world. You're being impractical, Rob. What the heck? 3. Okay, 3 files, no problem. 10, starting to be a lot of HTTP requests. As we're moving towards more CPUs, we're going to move towards more web workers because it makes sense. If you're dealing with a really in-depth application, it makes sense to have those. The other aspect that really screws us up, because you can do that. You can have everything else minified in these couple extra files that you just include sort of outside your normal minification system, sort of, outside of, if you're using Rails, for example, sprockets, require stuffs. That works for your own code. But what about libraries? Who here uses, let's say, at least one JavaScript library? Okay, thank God. JavaScript libraries, it doesn't make sense to limit just your own code to using a web worker. If this is really sort of how we're going to extract the power out of websites, out of the web, then libraries should be using it too. Libraries should be optimized in this way if it makes sense to optimize them. So, all right, everything we have right now deals with this minification, concatenation stuff. It's set up so that when you have a library, that library gets put into the giant, horrible mess of JavaScript file, and it's not like it has a separate file. There's no provision for that as it currently stands. It's getting just thrown in there with the rest of it. So there's no room for it to have its own sort of special web worker URL somewhere. Maybe in Rails where everything's really tightly bound, but you start looking at the new things that people are doing in JavaScript and Node, and they're not really, you wouldn't be able to create sort of another URL for this web worker URL, and you wouldn't want to for all the performance issues that I was talking about earlier. So that's a really long way of saying this isn't quite the simplest version, but this is the only version that I view as practical as we start to get into this further. The key to getting your web worker to be happy, to play happily with the minification and all that, with the combining of these files, is to throw it into a function. And I'll come back to this in a little bit, but you guys just have to trust me for now. There's a little bit of magic going on here. This function will not have access to any variables outside of it. So whereas a normal JavaScript function, I totally would have access to this use web workers variable inside of there because it's in a scope outside of it. closures and all that. We're not going to get access to that in this scenario because we're doing a little bit of, well, not a little bit, quite a lot of a hack to get this working. But let's ignore that for a second. Let's see what's going on in here. Well, I'm not really going to go into the details too much. We're calculating the Fibonacci numbers from 0 to, well, until I close the web page. We're not stopping for any breaks. There's no set timeout 0 hacks here, so it's really just spinning the CPU as fast as it can go. This is us trying to get every single ounce of power out of the CPU. And then every 10 millionth iteration, we're posting a message back to the main process. And we're just saying, you know, what the Fibonacci number was at that iteration and the iteration number. Some people would have done prime numbers here. I actually don't really understand that algorithm yet. That's a to-do for me. All right, we'll scroll down. There's just a really quick if statement because, you know, there's this branching. We can either use the web worker or we can do sort of a imitation of it. This is the important bit. We're taking that worker function, which we defined, just scrolling up here, and we're calling toString on it. All right, here's a little quiz. What the hell does that do?
String representation of the function?
Yeah, it's actually giving you the text of the function, including that first line that says function in the end. Like it's giving you all this. That's the string I've just gotten. This is kind of crazy meta stuff at this point. Here be dragons, right? Yeah, sorry, without the variable name, yeah, I should say. That would be crazy. Yeah, just the function definition. All right, so we get that, and we're trying to convert it to make it look like a file that, like, you know, sort of the traditional web worker hello world, like a file that just has some instructions in it. Basically what we want at the end of the day, to say that another way, is we just want to have this content inside that function and put it into something that looks like a file and then have the browser load it as a web worker. So the first thing is we do a little regex to get rid of that function definition at the start. We get rid of the curly brace at the end. All right, cool. Now we're down to a string. It's just this stuff. All the crud's gone. That's why we couldn't access any variables outside the scope, because it's actually being loaded into a completely separate virtual machine. Well, mostly separate. I'm not actually sure how separate it is. I imagine implementations differ on that. So we've got this string. Again, blobs are back. Like I was saying, blobs are freaking everywhere. They're just this utility that come in so many times and are so useful. What we're doing this time is we're taking that string and we're creating what looks like a file. Why are we doing that? Okay, oh, sorry, one thing before that. Type text JavaScript, that's assigning a MIME type to it. We're gonna need that to, you know, get the browser to open this up as a JavaScript file in the web worker. It would complain bitterly otherwise. Next step, this is really getting to why we created that blob and why we went to all this trouble, is window.url, or in older versions of WebKit, WebKit URL, .createObject URL takes in a file descriptor, either a blob or a file object, and spits out a URL. Now, there's actually, this is a little similar to data URLs at this point, actually, because we took in some text and we converted it into this sort of URL that we can then reference, that references this dynamically created file. It's really quite a lot like data URLs. The reason why I use blobs always over data URLs at this point is because there's a size limitation to data URLs. Also, you have to encode it, which takes up some time, but that's really trivial. Data URLs work sometimes for small files, like images, like fonts. You know, we use them in CSS all the time. But for large files, you can't use that. Some browsers, I think it's 32K where they cut off. So really actually quite low. That's based on a Stack Overflow answer. I don't know if that's true. But I definitely remember reaching that limit myself. Just don't remember what it was. The last thing here, we've got that URL, we're good to go. This is actually where a normal hello world would start. We create a web worker. And now there's a process running. There's a second process running in the background, which is running this loop, which is running this, insane Fibonacci numbers for the rest of eternity. Okay, one last thing. We're adding an event listener. So in our web worker, just going back a little bit, sorry for the scrolling, we're calling post message. That's a function which the web worker has. When you're inside a web worker, you have this function made available to you called post message, which allows you to communicate back with the main process, back with the thing that spawned it. And the opposite side of that, the converse sort of opposite end, is the event listener on that worker. So we can add an event listener for a message and then receive that data that was sent to us from the other process. So it pops over back into us, gets put into our event queue, and then all we're doing is just console.logging it. It's, fairly trivial. Just something to show what's going on. Okay, and past that, nothing really exciting. That's just, the version of this which would run in the web browser. So let's try it out. So here's our web worker example. Notice the first number was infinity. That gives an idea of just how much calculations just happened on my computer. It was a lot. And the number of iterations is at 100 million iterations at this point. We're going to reach 1 billion pretty quickly. I just want to give like a scale of how much computation is happening here. Well, I'm able to just work happily. Like I can, there's no responsiveness issues right now. Meanwhile, another core on my computer is like dying with the stress of this thing, right? If we go into HTOP, we see it just pegged right there. If I close it again, just for a comparison, let's watch. Right? So this is pretty taxing, but Fox jumped over the, what was it? Something brown, sure, let's go with that. I never remember that one. But yeah, it works. Like it's totally usable as a web page. People aren't gonna be freaking out. Let's try it without the web worker, he said mischievously. Okay, well, that looks like a web page. I can't actually press Command-Alt-J. I'm gonna have to close that and open it again so that I can hit Command-Alt-J and bring up the web console. So, all right, it's running, pretty much the same as last time. Let's try, okay, we can't click things. And we can't select text. Nothing works in this browser. If you wanted to sort of have the like perfect, horrible user experience, it is this. It's like the ultimate frustration. In fact, I can't even reload the page. Nothing works at this point. So that's really where it comes in. Cool, so that's sort of the basics there. You use web workers when you've got some horribly computationally intensive task, which is just going to kill your CPU and kill your user experience and possibly frustrate the user to the point where they kill themselves. Hopefully not. Last example, and this was totally not even prepared for this, so it's CoffeeScript. Everyone have a good old hate on CoffeeScript. There, okay, oh man, we have a supporter. I expected like a pitchfork to be in that hand. I was quite pleased to see someone liking CoffeeScript. So I'm gonna skip over this first bit. What's going on up there, for those of you who have messed with it, I'm just creating a very basic Express server. For those of you who haven't, I'm just creating a very basic server. So once I've got that server set up, I'm importing socket.io. This is probably the easiest way to create a WebSocket in Node. Oh, by the way, this is in Node. I feel like I skipped over that somehow. So what we're creating here is a Node web server that's going to have the server side of the socket and then JavaScript in the browser, which is going to deal with sort of the client side of the WebSocket. And we're going to establish this two-way communication between them. We're requiring socket.io. We're telling it to listen on that server. We're setting the log level to 1. This is just in case you don't want to have infinite amount of logs coming at you, it will tell you every single time a message is sent. And in this particular one, it was driving me nuts and actually slowing the site down a ton. So most of the time, unless you're debugging, you probably want to set that to 1. Okay, on connection, so whenever a client connects, whenever there's a WebSocket opened by one of the browsers that's on your site, and then, sorry, this is a function, by the way, for people not from the CoffeeScript world. When that connection's opened, we then start listening for mouse move events from that connection. This isn't the DOM event. This is an event that I named the same as the DOM event. So don't get confused there. Again, this wasn't created initially to be demoed. It was just sort of something I created for the hell of it. But it actually worked out reasonably well as a demo. So the next thing here is whenever we receive a mouse move from one client, we broadcast it back to all the other clients. So that's what we're doing with the socket.broadcast function there. We could also send it to particular clients with, just emitting to particular clients. But broadcast in this case is exactly what I want to do. I want to emit an event to all the other clients, telling them that one of the clients has had a mouse move. So if this looks familiar, it's basically an echo server. There's really not much in there. But you could definitely use the broadcast if you have like site-wide events that you need to push to everyone. If you're having something stream out to your users, more important than mouse movements, you could push it out through broadcast. On the client side, again, there's really not much here. I set up my socket, I connect to the URL that it's at, I scroll through a whole bunch of implementation details about the specific business logic of this scenario, which I'm going to kind of leave as a surprise for now. And then down here on document ready, we're saying on mouse move. So whenever we receive one of those broadcast mouse move events from the server, we're going to call this callback. And on the other end, on us actually sending events to the server, we're listening to the document, mouse move events, and then we're grabbing the position of the mouse, and we're sending that through our connection to the server, which again, then broadcasts it to everyone else. Kind of a nice thing about that broadcast method, because it's defined on this socket, this client, this particular client, that event that's getting sent out to everyone actually doesn't get sent out to you. So it's kind of nice. You already knew that stuff. There's no point to just sort of waste time sending you something you just told the server. So that's sort of the basics of this example. Let's spin it up on Heroku and wait for my single dyno to do its thing. By the way, I highly encourage people here to go to this URL right now.
Can you zoom in on it?
Yeah. Oh, we got a long time to wait anyways. I suppose in hindsight, this is when you get like a second dyno about an hour before the presentation, but okay, it's not going to load. Basically, it was a site where it sort of tracked everyone's mice. They showed up as mice on the other screen. It got really confusing which mouse was yours, and it flashed weird colors. But yeah, that's sort of a very practical, no, not practical at all way to use web workers or WebSockets. Sort of a next generation replacement for Ajax, which gives you really useful bidirectional communication with the server that you don't, oh, we're up, oh my God. Oh my God, power of the internet. So you can see through the magic of the internet, we have here lots of mice on a single screen. This is what I'll be remembered for. Okay, so that's a less practical thing you can do with WebSockets, but realistically, it's a whole lot better than long polling, if you guys are familiar with that. It's really easy to use. It's all in pretty much every browser at this point, unless you're working for the government who requires you to go back to Internet Explorer -2. You should totally be using this. And that's really my sort of introduction to everything in JavaScript I learned in the last year. That's pretty much it. Thanks, guys.